So algebraic expressions are a lot like what we see of as equations. They're just missing one thing. The big difference between expressions and equations is equations have equal signs. Expressions don't. So expressions can be made up of several different things. They can be made up of numbers, but they can also be made up with variables. So a variable, as you read right there in the book, is a letter used to represent one or more numbers. Now the reason we use a variable is right in the definition of the word variable. Anybody know what variable means? Break it up into two pieces, yeah.
It could change.
It could change. Okay, so you got the root word vary, which means to change, and able, which means super awesome math teacher. Okay? But I don't change. So we're going to take the other definition here, which means able to change. So that's what a variable is. We use it to represent a quantity that we want to be able to change. Now, we can combine letters and numbers, variables and numbers, with any operation we want. Addition, subtraction, multiplication, division, exponents, radicals, however we want to put them together. Today what we're going to be looking at is how to evaluate expressions. And the way we evaluate expressions is very simple. We take the value that we're given for the variable and plug it in and simplify. So example 1 tells us to evaluate the expressions that they give you when n equals 3. So let's take them piece by piece. The first expression is 13 times n. 13 times n. Now in this case, they tell us n is 3. And it's only 3 because they told us it was 3. Okay, when you see an n later in your book, don't go, oh, I remember from the first lesson that n was 3. No, n is 3 this time, not every time. N is 3 this time because they told me that n is 3. Okay? Don't lock that into your head and now you'll never remember what n could be. N is always 3, I don't know what to do. No, n is 3 because they told us it's 3 this time. Okay? So we're going to replace that n with 3 and multiply. What is 13 times 3? Somebody without using a calculator. 39. So 39 is our answer. 39 is the value of 13 times n when n equals 3. If n equaled something different, then 13 times n would be different. The next one is 9 divided by n. So in this time, n is 3. What is 9 divided by 3? David, 3. So the value of 9 divided by n when n is 3 is 3. Everybody follow? If I'm going too fast, just throw something at me. Get my attention. Something that's not going to kill me. I mean, you could also raise your hand, but sometimes I get a little tunnel vision. Not at that kid. Definitely not at that kid. All right. Next one is n minus 1. Now, some of these you'll be able to do, you'll be tempted to do in your head. N minus 1, n is 3. What do we think n minus 1 is if n is 3? Lauren, 2. Because if we replace n with 3, 3 minus 1 is 2. There's another thing we should do on our homework. Circle our answer. Makes it easier to find. And the last one in this section, n plus 8. So if n is 3, what is the value of n plus 8? Bethany? 11. Everybody follow so far? Make sense? Yes? Awesome. That's example 1. Wow, You guys just made it through your first example. Good job. Let's look at example 2. The total cost of seeing a movie at a theater can be represented by the expression A plus R. Now, we got to keep reading the problem. A is the cost in dollars of admission. And R is the cost in dollars of refreshments. Everybody follow so far? It's important when you're approaching a problem to know what everything means. Okay. In addition, it's not so difficult because you could add in any order. But if we're subtracting or dividing or using exponents or whatever, you need to know which numbers are going to go in for which variables. So they tell us that $7.50, you pay $7.50 for admission. That's not bad. And $7.25 for refreshments. So you got one piece of popcorn. That was a joke about how expensive movie refreshments are. $7.25. You got one piece. You ruined the joke because I had to explain it now, Kyla. It's your fault. So what are we paying for admission, Allison? $7.50. And Caleb, what are we paying for refreshments? $7.25. Enjoy your single kernel of popcorn. Your one snow cap. You're half a Sour Patch Kid. I always feel guilty about biting those things in half. You would. You guys are brutal. So we need to take what A is, which is $7.50, and what R is, which is $7.25, and do what they told us to do. A plus R. So we're going to add those together. Now, hopefully when you approach this problem, if I told you went to the movies and you spent $7.50 on the ticket and $7.25 on the snacks, you would know how to figure out how much total you paid. So what we're doing is we're taking the things you already know and equating them to these new algebraic expressions and just tying everything together. So what is the total amount you spent at the movies? David? $14.75. And in 17 more years, Columbus will sail the ocean blue. That was $14.75. Sailed the ocean blue in $14.92. We're getting there. We're getting there. All right. By the end of the year, hopefully you'll be laughing like right after the joke. Oh wait, you're Cassie's sister. Okay. All right. Okay, we're good. We got a curve there. Okay, got it. Now you can show her this video on YouTube later. You can say, "Hey, Mr. Larkin hasn't forgotten you." All right, everybody get so far? Any questions yet? All right, so moving along, how many of you have seen powers before? As in exponents? Yeah, okay. All right, so here's how we write these. A power is two pieces. It's got a base and an exponent. The base is the big number at the bottom. The exponent is a little number written up to the top right. Okay, so there's two parts, the base and the exponent. And what a power does is it tells you to multiply the base by itself the exponent number of times. So in this case, if we have 3 to the 4th power, that's how we read it, we would do 3 times 3 times 3 times 3. This is not 3 times 4. This is not 3 plus itself 4 times. It's 3 times 3 times 3 times 3. 4 3's being multiplied together. Everybody get so far? Now, what if I had an exponent of 1? What is 7 multiplied by itself only once? Yeah. 7. It's just 1 7. There's no other 7 to multiply by. I don't have 2 7s to multiply. I just have 1 7, and it goes nowhere. It's just 7. That's a tough one, right? Whenever you have an exponent of 1, it just stays the same. It's kind of sad. Poor 7. All right. Now the next one is 5 to the second power, or what's another way of saying to the second power? Does anybody know? Seth? Squared. We could read it as 5 squared. So this is the same, if we want to write this as a product, as 5 times 5. So in your homework, it might tell you to write it out in words. So you would write 5 to the second power, or 5 squared. And then it will say write it as a product. So you'd write 5 times 5. And of course, if we multiplied it out, what would we get? 25. 5 times 5. All right, then a fraction. 1/2 to the third power. What's another way of saying to the third power? Does anybody know how to say to the third power? Emily. Cubed. 1/2 cubed. As a product is 1/2 times 1/2 times 1/2. Now, if we remember how to multiply fractions, we multiply across the top and across the bottom. So this would be the same. Now, this isn't part of the answer that you do in your homework, but in this would be the same as doing 1 cubed over 2 cubed, because when we multiply across the top, we got 1 times 1 times 1. And on the bottom, 2 times 2 times 2. So we'll get into fractions with exponents a little more later. The last one is z to the 5th. Z to the 5th power. There's no shortcut for to the 5th power, at least not that you're going to learn. We got z times z times z times z times z. How many times? 5 times. All right, hang on just a second. Let me run you through a couple here real quick. If we wanted to evaluate an expression, x to the 4th, when x equals 2, what would we do? Seth?
You do 2 to the 4th power.
2 to the 4th power. And what would we get? What is 2 to the 4th power? 2 times 2 times 2 times 2. What would that equal? Yeah. 16. Now the weirder one is when you have exponents, decimals with exponents. N to the 3rd when n equals 1.5. Oh look, n is something different now. It's crazy. So we would do 1.5 times 1.5 times 1.5. And I'll do it for you real quick in my head or looking at the book and getting 3.375. Everybody good with that? Now the last example talks about a storage cube. Now what do we know about cubes? What can you tell me about cubes? Yes?
They're three-dimensional.
They're three-dimensional. What else? How about all the dimensions are the same? It's the same height as width as length. So if I want to find the volume of a cube, I take one side length and raise it to the 3rd power. In other words, I cube it. That's where the cubed term comes from. So if I have a storage cube that's 14 inches on a side, I do 14 to the 3rd power, and I get 2,744. And if my 14 was inches, then my volume is inches cubed, just like I did with the number. Are there any questions?